Hello ma'am, my name is Kalyan Sharma and I am currently pursuing my BTech in Electronics and Communication Engineering at NIT Goa. I have deep interest in IoT and embedded system. So I have worked on this uh, project and learned some basics of and advanced level of mm, programming, IoT program. In this video, we will see how I have made this project and how my project is working. So project name is home automation. So, and I have done actually under the supervision of Jayalaxmi ma'am. So thank you ma'am for this opportunity. Let's move to the next. So in in this PPT actually I have mentioned all the things like about the internship, C++ OOPS concept, and then what we have learned during the internship, IoT, then embedded system, then problem statement of this what we have made actually, then objectives of these problem statements, then tools used, we have used, output images of the setup and home automation, and then conclusion. So let's move to. So first I'll discuss about the internship. So this is the internship provided by Emergency Information Technology Bangalore. So this is offered for a duration of 4 weeks. This is organized basically and a structure and a standard internship, and they taught us well and very basic to advanced level. Uh, this internship was me. Was aim had a aim of learning with implementation. So first Jayalaxmi ma'am taught us and then implement the same problem and same things on Pixim lab. Then students will obviously they provide a student support model LMS. This is learning management system and free resources and tools they provide. Project based learning, so they provide do practice project weekly evaluation. Yeah, they take like weekly test and then provide the result of the students. Move to the next slide. Yeah. So so what we have learned, first of all we have started with C and C++ oops. So in C++ oops we have learned some basics, then intermediate, then advanced. In basics we have learned variables, keywords, data types, operators, conditionals, and then loops. And then in intermediates, arrays, pointer, functions, storage classes, files, preprocessors. In advanced C++ overview, first of all the Jayalaxmi ma'am has given, and then class and object, about the and about abstraction, and then inheritance, encapsulation, polymer feature. So first we'll move to the basics. So what is variable? Variable is basically uh, a name of the storage location in the memory which holds data basically. So memory, in memory whatever we have uh, whatever we put the data, so they are stored in a memory location. That memory location is identified by that variable. Like for example, here int is equal to 25. So here 25 is stored in a memory, and we have given that memory location name as age. So this age is basically variable. Here height is 5.9. So 5.9 is stored in the memory, but height, what is the memory location name? So this is height, and here also same thing. Character and age is stored in grade. Now keywords basically in C, C++, in any language, whatever you take, even other than C, C++, also some reserved words are there. So uh, you, other same words basically you can't use uh, for other purposes, like yeah, int is reserved, main is reserved, return is reserved, like printf, scanf, etc. Uh, so total 32 keywords are reserved in C basically, and and they have a special meaning to the compiler basically. If I am writing here int, then it means integer. If I am writing main, so it means a function name, and then return, then function is returning something. So compiler understands like that. Third, we will move to data types. Data types define the type of data a variable can hold. So like I have already explained variable. So here is height, grade. These are the variable, and these are storing the values 25, 5.9a. So data type is basically which type of data is like 25. 25 is what? Integer. So integer data type. So this is data type. Here what is 5.9? 5.9 is float type. Like so it is data type float. It's showing the data type of the uh, 5.9. And same thing here, character. So a is character basically, so it's showing the character data type. So this is what here also you can see int number we are storing 10, so 10 is integer, so we have mentioned here int data type. Here 36.5, so it is float, so float data type. Similarly we can use double also, like double it can give up to 6 to 7 points after decimal. So this is like this takes basically more memory than float. Operators. Now what are operators? Operators basically symbols that perform the specific operations, and it uh, it's are basic these are basically arithmetic operators, logical operators, relational operators. For example, here I have taken one variable int a is equal to 10, where it's showing variable name. This is data values, and this is data type int. So two variable I have taken 10 and 5, which is stored in A and B. Now int sum, here plus is showing adding operation. So int sum is another variable which is storing the sum of the 10 plus 5. So 15 it will store. Same thing, bool result. Here bool is storing, bool store basically true or false of the result. Here we have used operator, logical operator. Here plus is arithmetic operators. So it's doing addition. Here it is doing logical operations, like whether a is greater or b is greater. So here it's checking a is greater. If a is greater, then it will return true, or if b is greater, then it will return false. So it will store uh, in result variable basically. So here 10 is greater than 5, so it will return true. So true will be stored in result variable basically. So now result is equal to a and ampersand and operation b basically. So this is also a logical operation. So it will do 10 and operation with 10 and 5. So first in compiler basically it will do like 10, it will be converted to 1010 in binary, and then 5 it will be converted to 010 010. So 010, so it will be stored in, and then it will be like calculated and operation between them, and then stored in that result. Now conditional statement. So conditional statements are basically, it is used as a block in like C programming or C++ programming. So it it is basically, it is basically showing the conditions. It shows the conditions in any loop. So the most common conditional statement is the if statement. So if statement, for example, int name is equal to 10. So if name is greater than 0. Here name equal to 10 we have assigned, so name is storing 10 value, so 10 is greater than 0 obviously, so printf will be positive number. Yeah, so we can say it is positive number. 10 is positive number here, so it will print positive number. Else if num is a minus or something else, minus or like in negative, so it will print non-positive number, that means negative number. So this is how it's work. Like if it will check this condition, if it is not working this, then it will go to next condition. So yes, now we will move to loops. So loops are used to execute a block of code repeatedly until a certain condition is met. Common loops in C++ are for, while, and do while loop. So in C++ programming, basically, JMM has taught three loops basically. First one is loop, then while, then do while. So these are basically block of code. So if you want to do some specific operations in time, so we no need to do like each time in time. We can implement a loop, basically a block of code that will do in time. We will be doing one time only, but that loop will work n time, so it will be counted as n time work. So uh, for example, see here we have implemented for loop. So for loop, this is the syntax of for loop. Here we are printing I value. So for initializes something value, then there must be a condition, right, to stop the loop, otherwise it will go to infinite or something. So we have to give condition like how much till it should run, then I we shouldn't, we can increment or decrement here also according to condition. So here we have printed I, right? So percentage gsp format a specifier, so I is integer, so we have used percentage d. So percentage d here I 0, so first value it will print 0, then again it will check, then it will, since it is incremented, so it will go to I is equal to 1, then here it will come I is equal to 1, which is it greater, sorry, less than 5. So yes, this condition is true, then again it will go in this loop and it will print. So 1 first 0, then 1, then again it will go to incremented by 1, then it check 2 is less than 5, yes true, so it will again, it will print again to 0 1 2 3 4, and then it reaches 5 after 4, it reaches 5, then 5 is less than 5, no, false. So it will come out of the loop basically. So it will print 0 1 2 3 4. Similarly here this same thing will be doing here, but in a different manner, like different syntax using here we have initialized count instead of I. Instead of I, we have initialized count from 0, and this will check whether count is less than 5 or not. Then if less than 5, then it will print and go in the loop, or if not, then it will come out of the loop. So count 0 0 is less than 5, so it will print 0, then count plus plus, it count is incremented by 1, so count plus plus count is 1, then so 1 is less than 5, so again it will print 1, then 2 is also less than 5, so 2 will be printed, then 3 is less than 5, so 3 will be printed, 4 is less than 5, so 4 will be printed, 5 is less than 5, no, it's not, so it will come out of the loop. Similarly do while loop. So do while loop, I have initialized one variable named in, and we have given some one value 0, so we have initialized this variable with 0. Now it will first print, then it will check the condition. So whatever you value or whatever you have written, first it will execute. This is the difference between others two loop, for and while, and this do while loop. So even first time it will, even conditions were wrong, like even if you have given n is equal to 5, so it will print 5, then it will check 5 less than 5, 5 is it 5 less than 5. So this is the drawback of this loop, so it will run at least one time. So printf will do. So 0 will go, then again 1 will print, 2 will print, 3 will print, 4 will print, then 4 will print, uh, and then similarly it will be printed. An array is a collection of elements. So we have moved to next topic, intermediates intermediate topic of C++. So array, what are array? So we have already seen variables. So if you want to store multiple variable of same data type, like integer, we want to 10 integer, 5 integer. Let's say we want to store roll number of the students. So if we can't store, like we can't create hundreds or like thousands of variable, right? This is practically not possible. So in C++, we can declare an array, or there we can store the roll number, etc. Roll number, or if you want to store section, batch number, subject, etc. So we can store there in a same contiguous memory location. So this is important, basically contiguous memory allocation. So contiguous memory allocation means after it should be consecutive. Like if one is storing in 1000, so 2 will be stored just 4 byte after that. So 1004 memory location. 3 will be stored at 1008 memory location, like that. So it should be continuous. So how we have declared, like int numbers of 5. So we have declared 5 variables, so we have to mention 5. uh, so int numbers 5. So numbers is an array now. So here we can see how we can access an array. So int I is equal to 0 0. So it will go inside the loop. Since 0 is less than 5, so it will go inside the loop. Now numbers of I means numbers of 0. I is 0, right? So numbers of 0 means this element, numbers of 1 means this element, numbers of 2 means this element, numbers of 3 means this element, numbers of 4 means this element. We can't write numbers of 5, since we can't access numbers of 5, because numbers of these are arrays are basically zero indexing, so zero index based. So this will be numbers of 0, numbers of 1, numbers of 2, numbers of 3, numbers of 4. If we run numbers of 5, we will get some error. So although we can like mention here numbers of 5 if you writing or like declaring the array, but we can't access that element since it will go out of the loop. So till numbers of 4 we can mention. So numbers of 0 is 1 2 3 4 5, so it will be printed like that. Now next topic is pointers. So pointer is a variable that stores the memory address of another variable. Let's say we want to access some variable we have stored in a memory location. Let's say we want to access that variable, but we don't know the variable name, but we know the memory location. So how can we access? So where it is used? So here we can use pointer basically. So pointer store memory address of another variable. So let's say we have one variable named as var, which stores value 10. Now address of this variable var address of this variable will be stored in a pointer which named as ptr. So declaration is int star ptr, pointer is declared like that. And then ampersand var, we have to write like ampersand shows the address of the var is the variable, and ampersand shows the address of this var variable. So here we can use. And now if you want to access this variable, so directly we can write cout or like printf a star ptr. If you write, then it will give the value of this variable, like 10 it will give. If you put directly ptr, then it will give address of this variable. So this is how it works. Now it will move to functions are basically block of code that perform a specific task. Like if you want to use same line of code, same block of code in 100 times, then there is no meaning of writing again and again. So we can declare a function so that it can work 100 times whenever we call that. So that's how it function works. They help, so they actually help to solve the complex problem into a smaller and manageable. So for example, we have taken one function, we have made one function int add. Int add is taking two variables int a int b and returning a plus b. So what is this doing? Whenever we call the variable inside the main, so add 5 3, so it will call the function this one. Here you can see calling the function, so it will call the function this one, add 5 3 and return what is returning a plus b. So 5 plus 3 a, so this value will be copied here a and 3 will be copied here b, and then it will return a plus b. So 5 plus 3 it will return 8. So now since this value is returning 8, so the 8 will be stored in result value and the result will be printed here. So result is equal to 8, 8 will be printed here. So how it works, if we like add one if you call if you want to call another time, like add 6 comma 3, then again it will call this one and again it will print. Like if you want to call 1000 times, then 1000 times you can call. Simply adding this line you can call 1000 lines, or like no need to write this one again and again. This is how function works. Now we'll move to the storage classes. So storage classes in C are used to determine the lifetime, visibility, memory location, and initial values of variable. The common storage classes are auto register, static, and external. Basically, automatic, auto, external, static, register. So default storage classes for local variable inside function with a limited life to the function execution and visibility only within the function, not outside the function. And in external, if you see here, so used for global variables, making them accessible across multiple files. So the variables left with the entire runtime of the program and it is stored in the global memory. So it can be accessed like anywhere in the program, since it is global variable used for global variable, and it is external basically. And a static keeps the variable value across multiple function calls with the scope limited to the function of file where it is declared, but with the lifetime throughout the program execution. Exactly. So whenever we will run the program, that time only it will be that is the basically lifetime of this static storage classes. Otherwise, it will be like of no use. So next is registers. This the variable should be stored in a CPU register for fast access rather than in memory. The lifetime is the same as auto, but visibility is limited to the block in which it is defined. Yeah. So if you want to like access or see, so it will be in the defined block only, or we can't access after out of the block. So wherever it is defined, there only we can access. Now we will move to C++ version. So it extends C with classes, objects, and other features, making it suitable for developing complex. So it is C extended part of C basically. So where in C++ basically we have scientists and other programmers who has developed this C++ programming language has just added oops basically. So that is extra only, otherwise all other things are same. Like in oops we study class and object abstraction and all that stuff, polymorphism, inheritance, uh, blah blah. So and in so here we also we can see we will see some points or like some things. So class and object. So class is basically blueprint for creating object, providing the structure for data and function that operate on the data. So these are basically uh, what do we call class, whatever is that. So it's like uh, a structure in C basically. In C it's like a structure in C, but here using class we can create various like thousands of data, and we can uh, create thousands of objects also, and we can call them one by one even. And for a large complex problem we can call it. And object is basically instance of this class basically. So it shows the we are type. Let's say for example in real life a vegetable is classed in carrot and lady finger. These all are object basically abstraction. So abstraction is basically concept of hiding complex implementation with detail of system, exposing only the necessary functionality to the user. In real life we can say, let's say we drive a car, but we are only we are we have we can see only the uh, handle of the car and like the dashboard and wheel, etc. But how their engine works, that we can't see, right? So we are seeing the basic operations or like uh, necessary functionality of function of the car basically, and we they had the complex implementation of the detail of the car. So that's how in programming also we had like programmer or had some complex data uh, to hide or like to secure your users data. Uh, Inheritance is feature that allows a new class to inherit properties and behavior attributes another for existing class. So one class can be inherited to another class. For example, uh, inheritance means we are extracting property from one class to another class. For example, in real life, basically, uh, if you want to make uh, cake, right? Cake. So we can use milk also, right? So some of the property of milk will be there in the cake or like in curd basically. So that is the real life example we can say. Like some of the we are inheriting curd from milk basically. This promotes code reusability and establishes a relationship between base and derived classes. Yes. So encapsulation is the practice bundle of data and methods that operate on the data into a single unit of class while restricting the access to some object component. Yeah, so in this basically class and object data are binding together basically. We do it. And in say in polymorphism basically uh, one function or like one uh, what do you call, one function, one operator can be used in different way, different manner. Polymorphism means it can take different shape basically, different, it can be treated as uh, uh, various types basically we can say, like one function with the same name but different variable can be there. Function operators, same plus operator can be used as uh, op, you for concatenating the string or adding the two integers or like two variables. Now we will move to the next one. What is IoT? So IoT is basically Internet of Things. So first question arises, what is internet? So internet is basically exchanging the data between computers, devices. So what whatever we share the data on using computers, how they communicate, that is what internet. So over internet we basically share the data. So that is internet. Like, and what is thing? What is thing? So thing is so it can be anything, but it should be smart or like it should must have sensors. Like a chair can be a thing. So but it should have sensor, like for example a smart chair can have sensor uh, which recognize or like which can detect posture maintained or not of a person. So we can connect the sensor to a smart chair and we can say it is a thing in IoT devices. So here you can see the IoT architecture of the uh, IoT architecture, sorry, Internet of Things architecture. So this is IoT gateway basically, and this is how we interact with IoT cloud and then device node. Say here we are and we use device node basically. So that is So IoT gateway and device node, this so medium between these are called intranet, and if IoT cloud and IoT gateway in between, it called internet. So now move to the, so what we have learned, or what it requires to build an IoT application. So first one is device programming. So for that we have learned embedded system. So the embedded system we have learned device programming, C, C++, microcontroller programming like Arduino, and like it needs some extra, but they these things like need to build an IoT application. So what is IoT gateway programming? Like gateway programming also we do like C, C++, Python, etc. These are IoT programming, gateway programming basically, and some protocol, IoT communication protocol. In IoT cloud, if you mention like receive and store data from devices or IoT gateway, so here we can see IoT gateway, like I from here we can like we share or receive data from here IoT cloud through this one only. If we are here, uh, we access the IoT cloud, then we data come through this way only, here to here, here like that. So, or if we share the data to, then it will go like this only. So this is how it works. So we now we will move to the next point. What is embedded system? So in embedded system is a combination of software and hardware designed to perform a specific task application. So we, like in real life, without a embedded system, even think about we can't think about real life applications, or like how a world can be changed without like it is not possible to move like single things in the world. For example, everything in this, even whatever I am explaining in the laptop, that this laptop is also a type of embedded system. Speakers, radios, wave, ATA, whatever you see, washing machine, refrigerator, smart TV, AC, security cameras, Wi-Fi modem, etc. All these all are basically embedded system, because these are made of software and hardware. So we can say, and these are all are doing some specific tasks, right? Camera is did security camera detecting some persons, and Wi-Fi modem is made for Wi-Fi, right? And refrigerator doing are doing, are providing oxidation process, like washing machine is washing the clothes, like. So here also here another example we can see, like a smartwatch, health monitoring device, medical. These all are based on embedded system. So we can't imagine even the life of embedded life in the world without embedded system. So so we can see types of embedded system, like real-time embedded system. So real-time embedded system, like whenever we want to want that thing, it should be like, even it should not take 1 or 2 seconds, even a 1 millisecond. It should be in real time. Whatever we have pressed, let's say we have on the camera, then it should be on at that time only. So these type of things are used in self-driving vehicle control, like automotive control basically. So we can't like even we can't give a 1 millisecond chance of, right? In aircraft also, time is very valuable. Medical devices also. So these are in a standalone embedded system. These are like uh, without a single use of another device. They are prepared alone basically. That's why we see it as a standalone. So these are independent devices basically. So digital camera we can see, musical players, washing machine, these are independent machines. So these are used as standalone. Network embedded systems, network embedded system. So home security systems, ATMs, automated teller machines, point of sale systems. So these all are network embedded systems. These are all needs network connections and all that. Mobile embedded systems, cell phones, laptops, smartwatches. So here we can see example of embedded system. Example of embedded system. So Okay, so here we can see dashboard like display in the car, watch all the traffic, MRI machines, and all that car, telephone, trains, whatever we see in the world, like most of the them made of memory system. So now we'll move to the our problem statement. But after learning all the stuff, we we are implementing the basically this all learning experience in a single project basically. So our program is to be home automation using Blynk app. So we can control the whatever like garden lights, temperature, heater, threshold temperature, water tank, inlet and outlet valves of water tank, and also you can show this water volume, how much water left in the tank. So and also we can you on like display also mobile app also you can show the things. So to control light brightness with brightness monitor temperature monitor water level in tank through Blynk app. So these all are we'll be doing in this project. Peripherals, what do we need? So basically Arduino UNO, temperature system, LED LDR module, serial tank, Blynk cloud, Blynk app. So these all are will be need will have need to make this project. Now tools use. So this like how it will be connected. So we will have one Blynk app. So it will send the message to Blynk server, correct? It will be connected to Blynk phone app basically, uh, that will be installed in our phone. This will be installed. These are all connected to this Arduino board. This Arduino board will see like give the output whether it should light should be on or off. That's how it will be. So here we can see this is circuital view of home automation, how like proper view of all circuit components, uh, all circuit components, how it will be working, how it will be connected. So here we can see this is display CLCD, here Arduino board, LDR sensor, which LDR sensor. These are detects whether sunlight is there or not. According to this LED will glow. Similarly, this is Blynk cloud. This will give information to Arduino whether we have to on or off the something, a cooler, heater, etc. Ethernet shield basically used to connect to the Ethernet, like internet basically. Now temperature system. This is used to connect to the cloud. A serial tank here we can see like outlet wave and inlet valve and outlet valve will be connected to here. According to whatever we information give, we can take it from here and we can control the serial tank also. Temperature system same thing, we can take information here and then we can show on the CLCD or like we can send a notification to the phone. Now Arduino board. So this is Arduino board. Here we can like connect USB cables or like we can through that we can upload the code in the Arduino board. Arduino code will be uploaded here. So uh, this is reset button basically, and this shows the whether transmitter receiver are working or not. This is LED bulb, and these all are the pins that are used to used in input and output. So main thing is that this is using this one microcontroller. Basically this is microcontroller, this bigger one, and this is this name its name is 80 mega 328 pin microcontroller. About the project, this is basically ETH W5500. This is basically Ethernet shield that will be used to control and like send the cloud or connect to internet, and it follows some protocol according to talk to the like mobile application, between mobile applications and the Arduino board and all that. Now this is LDR sensor. Basically we can from here we can control the register, and uh, we can see the light intensity will be changes accordingly. If more light is there, if more light is there like sunlight is there, then it will resistance will be like uh, more light will be there, then the resistance will be very high, and so sorry, if more light is there, then resistance will be uh, very low and current, so LED will be off. And then similarly, if less light is sunlight is there, then resistance will be very less, and then LED will glow more. Now this is basically L CLCD connector. This its name is PC8574. Here we connect this pin to the Arduino board, to or temperature serial tank, or temperature sensor basically, so that it can connect to this one CLCD and show the temperature and volume value. This is the output of home automation and circuit setup. How you will, this is CLCD basically. This is PCFET 574 silicon CMOS circuit. This is LDR sensor. LDR means light dependent resistors. This is heater and cooler, and this is Ethernet field basically, and this is LED. So we will see next. It's showing on display. It's showing temperature and volume. Here we can see the how serial tank, or like a water tank is filled here, and it's showing the 2300 liter value. Here also we can see 23 liter value, and here we can see also CCR setting 2300 liter value. So how this is work now? Yes. So here we have basically on the value. So uh, out, 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 outflow is on and inflow is off. So this is inflow, here you can see it is off, and this is on. So water is flowing outside, so outflow, and cooler is on, so it's running basically and cooling the uh, room basically. So now so now we'll move to the how project works. So now I'll show you the how project works. How project works. So uh, yes. So now we will see how project it works. So first I will show you the how LDR is controlling the LEDs of light. So here you see, first I will load the code. Yes. So this is our code. Yes. So code is loaded, and now we can see how if you see here how LED is glowing, and like it's getting off after decreasing this. See, you have seen this, correct? So, and this one also, here also we can see. Okay. Now how do I mirror? So now I will see the how using mobile phone we can control the these all things. No. Yes. Zero, 0, 3, 4. Yes. Yes. So here you can see, here you can see, uh, uh, see here, if you see here, this is my smartphone. I will show you. Let's say we see here, just see here, I will do cooler on, so it will show, see, this is getting on and this is cooler on, it's showing, it will be on. Now let's say I have clicked on cooler off, yeah, so it is getting off. Here you can see cooler is off. Now let's say we are click on cooler heater on, so now it's showing cooler heater on and it will go till 35 degrees Celsius. Here you will see automatically it will go off. Till 35 it will go and then it will be off. So 32, and it's here also, if you say temperature range is changing, see here, heater 34, 30, so it is also changing. And now see, you can see heater is off. Now if we run cooler on, then temperature will decrease. Cooler is on and temperature is decreasing. Okay, so if you see, now what we will do is, now I am making it cooler off. Now I am making it outlet wave valve is off, on, sorry, basically. So if we on the, see, water level is decreasing basically, and here also if you see, this value is decreasing fastly. See, this value is decreasing fastly, and till 2000 it is decreasing, and after that, uh, if we reach less than 2000, it will again it will be inlet valve is on, and this will be outlet valve will be off, because we don't want to make it less than 2000 data. So again outlet valve will be, if you see here, it will go till 2000 later, it will go till here. Outlet flow is on, here also we can say, and inlet flow again it will be, see, inlet flow is on, because less than 2000 we can't give. So this is how its project is working. Yeah, even if you stop here, sorry, I have made inlet flow off, now outlet flow on I have made. So see, outlet flow off I have made. Now inlet flow on, yes, now I have made outlet flow off. So how it's working, if you see, heater is on also, if you made it, let's say heater is off, I have made it. So heater is on, if cooler is on, I have made. Now inlet valve is on, inflow is on, yeah. So if you see, yes, now if you see, yeah, if you check, yes. So as you can see, I am controlling the, now let's say cooler is off and heater is on, I am making, heater is on. Yes. So heater is on, and it will, yeah, heater is on and it is increasing the temperature. Here also, if you see the changes, you can see the changes. It will be going down. Sorry, there is a Wi-Fi problem. Sorry, sorry. So now, if you see here also, sorry, there is a Wi-Fi problem. Yeah, no, yes, now it is on. If you make it, yeah. Oh, sorry, there was a Wi-Fi problem, so I got disconnected. I'm really sorry. So have you have seen already basically. So now I will minimize it. Okay. So thank you, ma'am. Thank you for this opportunity. Thank you for this internship and all that. Whatever you have done is like, uh, I can't express and I can't tell you how much you have helped me to do this and how much I have learned. I'll be always grateful to you. Thank you, ma'am. So now I'll be going to conclusion part. So what you have seen is this home automation project efficiently integrates an Arduino UNO with Blynk for remote control and monitoring of temperature system. And this what is the and water tank LED brightness by utilizing virtual pins. Yeah. So the system enables real-time control of cooler, heater, and water valves while also displaying critical information on an LCD. Yeah, LCD where we are showing the temperature and cooler on is off, all the things. Okay. Thank you, ma'am. Thank you so much.